Hi guys, so we're going to run through vectors at A level. The only difference here is that instead of being 2D vectors, so just x's and y's, it's now a 3D vector. So first of all, that means that you're working with coordinates that are in 3D. So instead of having just an xy coordinate, it's now an x, y and z coordinate. And so that just means the distance from the origin to that point is just Pythagoras, but extended to include three terms, so x squared, y squared, and z squared. It then applies exactly the same, that if you're doing the distance between 2 points, so this is my coordinate 1 and my coordinate 2, you just do the difference in x's squared, the difference in y squared, the difference in z squareds. Okay, so all of that should be exactly the same as GCSE, apart from the fact that there's now 3 terms instead of 2. Something a little bit new is the 3D vectors are labelled using I, J and K. So they can be written either in I, J, K form or as a column vector. So the vector I means that it's 1, 0, 0. J is 0, 1, 0, K is 0, 0, 1. So in other words, you've got basically that's your I, that's your J, and that's your K value in terms of a column vector. You will find 90% of the stuff I do, I'll use column vectors just purely because you don't have to keep writing I, J, and K. Okay, 3D vectors have the same addition and scalar multiplication rules as 2D vectors. There's a couple of examples in the book if you want to look, but to be honest, it's just to say that if I've got 3 lots of this, I get 3, 0, 0. It's same stuff from GCSE. 2 things we're going to use is magnitude of a vector is denoted with the modulus signs, okay? And magnitude just gives you the length of the vector, so it's basically Pythagoras again. Okay, using, obviously assuming A is pi, qj and rk, then you've got p squared, q squared and r squared. And then a unit vector just means that you're making your vector a length of 1, in which case it's denoted by a hat, and a hat is a over the modulus of a. Okay, that's just something that you're going to have to remember. I will double check if it's in the formula booklet, but I did forget to check before I started this video. So we're going to run through just a quick couple of examples. We've got, consider the points A and B. We want to find the position vector of A and B. So this is your coordinate. A position vector is that if you've got OA, so from O to A is just this, subtract basically the origin, which is obviously 0, 0, 0. So if I'm just subtracting 0 from everything, I get 1i plus 5j minus 2k, or it could be written as the column vector 1, 5 minus 2. Okay, just remember that if you're writing in I, J, K form, I, J and K are your vector terms, so they all need underlining because you'll typically see that they're written in bold. Okay, so we have to underline, which is why I tend to go with column vectors, just a little less hassle. They don't mind in the exam unless they specifically state to give the answer in a certain way. Either way is fine. Okay, and that means O to B in this case is just 0 in terms of I. You get minus 3j and plus 7k. So in terms of a column vector, it would be 0, minus 3, 7. And that's it. You've got your vectors for A and B. Right, find the vector A to B. Well, A to B, remember, you can think of this as a diagram. We know that if this point here is A, then that there is O to A, which could be labelled as the vector A. O to B could be labelled as the vector B. But notice that if I want to go from A to B, okay, just to show you why this works, if I want to go from A to B, I go from A to the origin, and then from the origin to B, so I go minus A plus B, in which case A to B is just your B term minus your A term. Okay, so I've got 0 minus 1 is minus 1, minus 3, take away another 5 is minus 8, and 7 minus minus 2 means I'm adding on 2, I get 9. So that would be my column vector for AB. Right, next point we've got is we've got the vectors A and B are given like this. This is something similar to what you'll have seen at GCSE. Find 4A, add B. That means for part A, you're doing 4 lots of this vector plus this one. So when you do a multiple of something, you just multiply everything in there by 4. So I get 4 times 2 is 8, add 4 is 12. 4 times minus 3 is minus 12, add on minus 2 gives us minus 14, and 20 add 0 is 20. That is my vector for 4a plus b. If I was going to find 2a minus 3b, I've got 2 lots of a minus 3 lots of b. Just be very careful with that extra minus. So I've got 4 minus 12 is minus 8. I've got minus 6 add 6 is going to give us 0. I've got 10 minus 0 is 10. And what they want us to do is we want to state with a reason whether each of these vectors is parallel to 4i minus 5k. Now, if they're parallel, one of them should be a multiple of the other. Now, 4i, 0j, and minus 5k is that one. This one is not a multiple of this, because obviously it's got a minus 14, and now multiple of 0 is going to equal minus 14, so it's not parallel. And then this one is actually minus 8, 0, 10 is actually minus 2 lots of 4, 0, minus 5, so therefore they are parallel. Okay, all it has to be is that one of them has to be a multiple of the other to make it parallel. Right, hopefully nothing too tricky so far. You've got find the magnitude of this vector. Now remember we said magnitude is just to write with the modulus signs. Okay, and you find that by doing Pythagoras. So you've got the square root of 2 squared, add minus 1 squared, add 4 squared. Okay, that's going to give us the square root of 21, and then hence find a hat, or the unit vector in the direction of a. So the unit vector is that you're going to want 1 over root 21. This is the length, don't forget, of our vector. If I want this length to become 1, I do 1 over root 21 times by our vector, so 2i minus j, add 4k, and that's it. That's my unit vector for a. Right, next part, we've got find the angle between a given vector and any coordinate axes by considering an appropriate right angle, or you can, once you've learnt this, just remember the formula. But basically, you've got x, y, and z. It takes a little bit of imagining. If x and y are on the page, for example, z would actually be standing directly up towards the camera. Okay, so if this is my vector here, if I want to find the angle between that vector and the x-axis in this example, then all I'm doing is creating a right angle at the x-axis, and there's my angle that I'm looking for. So I've got opposite, adjacent, and hypotenuse. So if I want the I want the angle. Because I'm using a unit vector, I can make this length 1, in which case I'm ignoring opposite, so I've got A and H. So if we want the angle, if I want cos of the angle is adjacent over hypotenuse, so that distance there is obviously x, and then the hypotenuse is the length of whatever our vector is. So you get cos of the angle is adjacent, which is x, over the hypotenuse, which is just the length of that line, which is modulus of a. Okay, so that's actually the formula that you need to remember. If you're then doing the angle at y or the angle at z, you just change this out for y or z, depending on which one you're finding. So on this first one, if we're finding the angle with the x-axis, all we're going to do is cos theta, and we just put a little x so that we know we're working with the x angle, is equal to x over, and then the modulus of a. Well, the modulus of a is, let's do that on the side first. Modulus of a is the square root of 2 squared plus minus 3 squared plus minus 1 squared. I get 4 and 9 is 13, 14, so I get root 14. Okay, so that's over root 14. Okay, and if we're doing this one, we're obviously saying the x direction that we've travelled there, so our x value was 2, so that would be a 2 in the, sorry, I just don't want to write it out again because I'm going to run out of space. That would be 2 over root 14, in which case angle x is equal to cos to the minus 1 of 2 over root 14. And it helps if I'm actually in degrees. Okay, angle to 1 decimal place is 57.7 degrees. Okay, you can do exactly the same with y. You'd get cos theta y is your y terms minus 3. So I get minus 3 over and then root 14. So your angle at y is cos to the minus 1 of minus 3 over root 14. That gives us 143.3 degrees. And then for z, exactly the same again, cos theta of z. Well, your z term is minus 1. So it's minus 1 over root 14. You get theta z is cos to the minus 1 of minus 1 over root 14. You get 105.5 degrees. Okay, just remember this is your vector x, y, z. So this is your x term, this is your y term, this is your z term. Don't forget to include the signs. Right, from there, our last example is you've got the points A and B have got the vectors 2i minus 3j minus k and 2i. I realised I didn't edit that question. So let's just find that question. Right, sorry about that, guys. You can guarantee I'm always going to make a mistake somewhere. So, as beautiful as my typed up worksheet was, what I've actually got is that this should be my 2 vectors relative to the fixed origin. We're going to find A, B. Obviously, A is mentioned first, so this is vector A. B is mentioned second, so this is vector B. And then we want to show that the triangle OAB is actually isosceles. So, first things first, just to get you an idea of what we're doing. Right, we know O to A, that's this one. We know O to B, that's this one. If I want A to B, well, A to B, remember like we did earlier, is just B minus A. So we're doing 3, 4, minus 1. Subtract 4, 2, 7. You end up with 3 minus 4 is minus 1. 4 minus 2 is 2. Minus 1 minus 7 makes minus 8. So that's my vector from A to B. And then all we want to do is to show this is isosceles, 2 of these lines have to be the same length. So if we do the modulus of O to A, you've got the square root of 4 squared, 2 squared, and 7 squared. You get 69 for that one. And then if we do the modulus of OB, that gives us 3 squared, 4 squared, and minus 1 squared. You get root 26. And then the last one, we're going to do the modulus of AB, which is minus 1 squared, 2 squared, and minus 8 squared. That gives us root 69. Since these two are the same length, so OA is equal to AB. Therefore, it's an isosceles triangle. Okay, because I know 2 of the sides are the same and 1 is different. Okay, hopefully that makes sense. Give us a shout if you get stuck.